So in today's video, we're going to take a look at the derivatives of inverse functions. And so if we have a function f of x, and we have f inverse as the inverse function of x, then we know that the derivative with respect to x of f inverse of x, so we can kind of denote it as like f inverse prime, is going to be given by 1 over f prime of f inverse of x. And so that is a bit, arbitrary at first, but I'm actually going to go ahead and do a very quick proof of this. I mean, it's quite a simple proof actually. So essentially, if we let y equal f inverse of x, then what we can go ahead and do is we can apply f to both sides in order to kind of get rid of this inverse over here, right? And so we can end up with f of y equals to x, right? Because we know that f of f inverse of x should just be equal to x, kind of by definition. And so then what we can do is we want to find dy by dx, and so what we can do is we can actually go ahead and apply the derivative operator to both sides, and so we'll end up with the derivative with respect to x of f of y is going to be equal to essentially the derivative with respect to x of x, which is just going to be 1. And so then all we have to do is just use the chain rule over here, because we have kind of a composition of functions. We have f and we have y. We're kind of taking y and inputting that into f. And so what we're going to do is we're going to have, first of all, the derivative of the outer function, so that's going to be f prime of y. And then we're going to multiply that by the derivative of the inner function. Well, what is the derivative of y with respect to x? Well, that's just going to be dy by dx. And this is all equal to 1. And so now all we have to do is just kind of divide by f prime of y in order to solve for dy by dx. So if we move over here, we'll get that dy by dx equals to 1 over f prime of y. But what is y? Well, we said that y is just going to be equal to f inverse of x. And so we'll end up with dy by dx, if we substitute, y equals f inverse of x, then we'll end up with 1 over f prime of f inverse of x. And so that right over there is the proof. It's actually quite a simple proof. And we're actually going to use the same principle when we look into the derivative of inverse trigonometric functions in the next video. So let's actually go ahead and apply this principle. So we have this function over here, f of x equals to 3x cubed plus 4x squared plus 7. And we're asked to find f inverse prime of 2, and we're given that f inverse of 1 equals 2. And so let's actually go ahead and try to solve for f inverse prime of 2. Well, if we use this kind of property over here, then all that we need to do is actually just find f prime of x, and then just substitute f inverse of 1 into f prime of x, or into 1 over f prime of x, actually. So what is f prime of x? Well, we know from the power rule that f prime of x is just going to be, we can take this 3 down here, make it a coefficient, and we'll end up with 9x cubed. And then over here, 4x squared, we can take this 2 and multiply it by 4. We'll end up with 8x. We just have to decrement the exponent. And then this 7 over here is going to disappear when we take the derivative, because it's a constant. And so then all we have to do now is we know that f inverse prime of 2 is just going to be equal to 1 over f prime of f inverse of 2. And we know that f inverse of 2, sorry, I meant to write. Okay, my apologies. It's supposed to be f inverse of 1. And so we know that f inverse prime of 1 is going to be given by 1 over f prime of f inverse of 1. And we know that f inverse of 1 is just 2, because we were given that, and given, I don't know why I wrote 2 over here, that was a mistake. So this is just going to be equal to 1 over f prime of 2, right, because we're just substituting. We know that this thing right over here is going to be equal to 2. And so then we just have to find what f prime of 2 is. So if this is f prime of x, then f prime of 2, we can just substitute for 2 for x, so we'll end up with 9 times 2 squared, which is 4, plus 8 times 2, which is going to be 16. This is what, 36 plus 16, which is 52. I hope that's correct. I don't know, my arithmetic is not very good. And so now we know that f inverse prime of 1 is just going to be equal to 1 over 52. Remember that we have to take the reciprocal at the end. And so that would be our final answer. So that's actually how you can apply the derivatives of inverse functions, and in the next video we're going to actually look at the derivatives of inverse trigonometric functions.